right, welcome back. Part 2 of our lesson 12 notes is for us to determine how to prove differentiability. In the first part, we talked about how to identify a problem with differentiability visually based on certain graph characteristics, corners, cusps, vertical tangents, total lack of continuity. What we're going to do now is talk about proving analytically that we have potentially differentiability or not have differentiability at a certain location. And the number one thing you have to remember, in order to prove we've got differentiability, we have to prove continuity. So, continuity proof. Blast from the past, Unit 1. If we're going to do the continuity proof first, which we have to, continuity at x equals -1. First thing to show is that I can get an f of -1. That f of -1 exists, and the best way to show that it exists is to cite its value. So f of -1 would be, by the definition of this function, -3. Okay. Next thing to do is a set of limits, a right limit, and a left limit at -1. Now, when we do this, if our function value exists, typically one of the left or right limits will also equal that function value. That doesn't happen on every case. There's always those weird functions where it's like f equals to this, f is this one, x equals 3, f of this one, x is not equal to 3. Where the left and right are the same thing, and the function value is something equal, something different. But most of the times it's the left side is one thing, the right side is one thing, and one of them is also the equals to. So this guy's also the equals to, the right side. So I'm going to go ahead and just cite that that's -3 because the right side is the f of -1. And this guy's the right side. He's the right side and he's the equal to. This guy's the left side. So I'll double check. Whoops. Make sure I'm doing that right. It's the opposite of -1 minus 4, which is also -3. We got everybody to come out to be -3, the function value and the limits. And so how we wrap that up, we say, let me get rid of this little thing. I'm going to squeeze this guy right here. F of -1 equals the limit as x approaches -1, f of x. Therefore, f continuous at x equals -1. Continuity proof first. I'll make a little note here. If continuity fails, we are automatically not differentiable. So if your goal is to prove differentiability, and you start with and you start as you have to with continuity, and the continuity doesn't work, you're done. But this particular function, the continuity worked, so differentiability is still in play. So here goes the next step. And of course I'm going to have to go on to another page because I write super big. And, oh, here we go. Oh, there we go. My smart notebook is just taking it slow. All right, so part 2. Differentiability. In order to do the differentiability proof, we have to be able to write the derivative. So, my first part, x squared plus x minus 3, derivative 2x plus 1. That's my derivative when x is greater than or equal to negative 1. Negative 1 is my derivative when x is less than negative 1. And once again, so here's me. I'm going to verify the continuity of f prime. The existence of the point I already have from the first part. So when I do this part, I only have to check the limits. And it's the limits, left and right, of f prime at negative 1. Okay, so 2 times negative 1 plus 1 is negative 1. And the left limit is just negative 1. So, therefore, my original f of x differentiable at negative 1. These just have to match. They don't have to be negative 1 because we were checking negative 1. They don't have to be negative 3. They just have to be the same. I basically just have to show that the limit of f prime as x approaches negative 1 exists. And the way I do that is by looking at the left and the right limit of f prime at negative 1 and showing that they come out to be the same value. There's a 100% chance that there is a continuity / differentiability proof on your test next week. That means it's 100% definitely there, gonna happen. I know it. We put it on there. I'm telling you. So I suggest practicing doing number 5 and then looking at the note key to see how it worked. A little bit of challenge maybe figuring out the derivatives. So it's good to really sort of refresh our memory on that. But remember, the biggest thing I can tell you is the continuity proof has to come first, and the continuity proof has to be complete. Function value, left and right limits. Differentiability part of the proof, just left and right limits of f prime.